Hello, and welcome to Generating Investigative Leads with Alternative Database Search Approaches, brought to you by Forensic and sponsored by Thermo Fisher Scientific. This is the first webinar in the 5-part 2021 Future Trends in Forensic DNA Technology series. My name is Michelle Taylor, Editor-in-Chief of Forensic, and I will be your moderator throughout. For today's webinar, you can earn 1 hour of continuing education credit. Following the conclusion of the webinar, you will receive an email with information on how to obtain CE credit documentation. We have a great lineup scheduled to present to you today, but before we begin, I'd like to take just a moment to cover a few logistics. At the end of the presentations, we will hold a question and answer session. To ask a question, click on the Ask a Question tab in the upper right corner of your screen. Please also note that the right side of the screen features an overview of today's webinar, as well as more information about our speakers. If you have a technical question during today's event, click on the Test Your Connection button at the bottom of your screen. From there, you can access additional webinar support. We also invite you to use the social media widgets beneath the webinar to share with your friends and colleagues. First, you will hear from genealogy, the Associate Director of the Center for Human Identification at the University of North Texas Health Science Center. He has over 15 years of research and development experience in bioinformatics and forensics with more than 70 publications. His research relates primarily to computational analysis and interpretation of DNA forensic data. The software programs he developed have been used by the federal and state government agencies to assist in solving criminal cases. Next, you will hear from Ray Wickenheiser, who is the director for the New York State Police Crime Lab System. He has over 36 years of forensic science experience, with 19 of those as a crime lab director in local and state crime laboratories. His areas of expertise include crime lab administration, investigative genetic genealogy, quality management, forensic DNA, serology, hair and fiber trace analysis, physical matching and comparison, glass fracture analysis, and forensic grain comparison.
Thanks, Michelle, for that introduction, and thanks Thermo Fisher for inviting me today. I'm going to talk about one of my recent papers published in the Journal of Forensic Sciences. In that paper, I compared 3 different approaches of searching relatives in DNA databases to assist a forensic investigation. Before I get into the details, I would like to share some numbers recently published by NIJ. According to a recent NIJ blog, there are 250,000 unsolved homicide cases in the US, and more than 100,000 cases were accumulated in the past 20 years alone. So there's so many unsolved cold cases, and we're desperately looking for tools that can help us to solve cold cases. DNA database is one of the most powerful tools that can assist in cold case investigation. For a typical case, you collect sample from crime scene, you send it to the lab and generate the DNA profile, typically the autosomal Y-STR profile, and then you search the Y-STR profile against the codest database and hope there's a direct match. If yes, you develop a lead for further investigation. But in many cases, you don't have a direct match. Then what you can do is to search for indirect match, which means the potential relatives of the forensic profile in DNA databases. There are 3 different approaches to search relatives depending on which database you search. Familial search uses the autosomal Y-STR profile search against the traditional autosomal Y-STR database like CODIS to look for first-degree relatives. Y-STR database search Y-STR database to look for any male relatives. And investigative genetic genealogy, or IgG, use the high-density SNP profiles to search against a SNP database to look for any relatives, close or distant, male or female. It doesn't matter which one you use, all these approaches need a certain degree of family or genealogy investigation. Either in a small family just contains some first-degree relatives or very distant relatives in a big family. And after you generate some leads through the database search, eventually you still need to get the sample from the suspect and generate a autosomal Y-STR profile to compare with the crime scene profile to confirm the identity. Next, I'm going to talk about the details of these approaches. Familial searching is to detect potential relatives of a forensic profile in a DNA database. And this is the workflow of familial searching process. You have a forensic profile generated from a crime scene sample, and you search against the DNA database, measure the similarity between the forensic profile and the offender profile, and then you rank the offender profile by similarities. And the similarity can be kinship index given a specific relationship or number of shared alleles. Because there are very limited number of STR loci, including CODIS, we may only detect the first-degree relatives with high confidence. So first-degree relative means the parent-child or forceps relationships. Now, after you rank offender profiles, the top candidates can be selected for further investigation. The top candidates are the most likely profile being the relatives of the forensic profile. And in the further investigation, you may use non-genetic information like age, place of residency to fill out the unrelated candidates. If the forensic profile is male, so you may use Y-STR profile to fill out the unrelated candidates. And in some cases, if the forensic profile is female, you may use mitochondrial DNA to fill out the unrelated. And the KLDLJ did use mitochondrial DNA in familial search. And after this test and the filtering, you have very good chance to detect relatives if they are really in the database. One of the reasons we believe familial search should work is based on this BJS report in 1996, correctional population in the United States. According to this report, at least 42.8% of jail inmates have close biological relatives who were incarcerated. Biological relatives means father, mother, brother, sister, and child. Spouses are usually not biological relatives. If we further break down into details, there were about 36.5% inmates had forceps incarcerated, and 22.8% had parents or children incarcerated, which means there are lots of first-degree relatives in the DNA database if all the inmates' DNA profile were entered into CODIS. And the current CODIS system contains about 20 STR loci, which is good enough to detect the first-degree relatives with pretty high confidence. And but for more distant relatives, probably not so accurate. These are the reasons why familial searching should work, and it did work and helped in many cases. One of the most famous familial search case was the Grim Sleeper case. This case was a serial killer case happened in Los Angeles more than 30 years ago. In this case, STR profile were generated from the evidence, but no direct match was found in the DNA database search. So in 2010, about 10 years ago, a familial search was conducted using certain kinship measure. 200 candidate profile were determined as potential relatives of this perpetrator for further investigation. And the Y-STR profile of these 200 candidates were also tested, and only one profile shared the exact same Y haplotype with the evidence profile, which belonged to Chris Franklin. So very likely the perpetrator of this case may be a close relative of Chris. Then police officer examine the birth record of his family and exclude the Chris' brother, but his father, Lonnie Franklin, could be the source of the DNA evidence. Then LAPD sent an undercover team to follow Lonnie Franklin and retrieve his DNA sample from a slice of pizza. And it turned out to be a match, so it solved the case. This is the first successful familial searching to solve a homicide case in the US. Y-STR database searching is very similar to familial searching. It follows almost the same workflow, but there's a few things that are different. First, you use a forensic Y-STR profile to search against Y-STR database, so which means you have to have a Y-STR database to search. Second, the similarity measure is different. For Y-STR, it compares the number of mismatch loci or steps between a pair of Y profile. And third, the first investigation types autosomal STR profiles of the candidates and the candidates' male relatives. And depending on how far you want to go, you may investigate the whole male lineage of the candidates. So why do we want to use Y? First of all, most violent crimes were committed by men. Here's some statistics summarized by DOJ. For example, 99% of the forcible rapes were committed by men. And Y chromosome is only inherited between males from father to sons. And so we can use Y chromosome to trace the male lineages. And this feature is very useful in forensic investigation. It can be used in kinship analysis missing person cases. Familial search can use Y to exclude unrelated candidates, and Y can also be used in mixture cases, infer ancestry, link multiple different cases, and through these many cases, you slowly accumulate a Y profile to build a Y database, and then you can use the Y database to search for male relatives and help solve some cases. There have been many successful Y database searching cases. I would like to talk about one good example, the Jack the Ripper case happening in China. This was also a serial killer case. Similar to the Grim Sleeper case, the autosomal STR profile was generated from the crime scene sample, but there was no direct match in the DNA database. Around 2013 or 2014, many crime labs in China started build their local Y databases. And the city where this case occurred also started build its own Y database. In 2016, the local police department relaunched an investigation of this cold case with the local Y database. And the perpetrator, Gao Chengyong, was tracked down after his uncle was arrested for a minor crime. So the process was that a man was arrested for a minor crime, and his Y profile entered into the Y database and matched with the evidence profile of this case. And then the police department investigated his family and used autosomal STR profile to confirm that the Gao Chengyong was the perpetrator of this case. So this case used Y profile to detect the uncle-nephew relationship, and the familial search would not be able to help in this case. Since Y-STR database searching is not very common in the United States, so I'd like to talk about a few other countries that have built their national Y database. China is the pioneer in Y databasing, and there have been at least 20 million Y profiles in their national database, and still rapidly increasing. The structure of the Y database is very similar to autosomal STR database. It contains the offender, veracity, forensic profiles, and it can be used for any case. Many provinces in China require typing both autosomal and the Y chromosome STR profiles for all the crime scene sample they collected. And then they will search both autosomal and Y STR profiles in the database search. And there has been at least tens of thousands of successful Y databasing search cases in China, and there are more cases with confession after arrests. And because the database size is so big, and to increase the discrimination power, China Y database require at least 35 Y markers. Singapore also have built their own national database. They plan to retype all 170 samples they stored by the end of last year, but probably delayed because of COVID-19. But anyway, that's the plan. And they mostly use the Y database for sexual assault cases. New Zealand and Australia also start their national Y database in the past few years. And the sample size may not be that big, but it's growing very fast. The the database of the New Zealand, Australia is very similar to Singapore. They mostly use for sexual assault cases, but the technical detail may be different for different countries. One good thing about Y databasing is that you don't need to pass new legislation specifically for Y markers, because the current DNA law do not specify which DNA marker to include in the database, so it should cover both autosomal and Y-STR markers. In this table, I only list 4 countries as examples, and we know there's several European countries have built their own Y database. One successful Y case I mentioned in my paper was from Netherlands. The third approach is the investigative genetic genealogy, or IgG. It was very hard in the past few years in the United States, and it did help solve lots of cold cases. This approach is similar to Y database searching in terms of detecting distant relatives, but the foundation is completely different. IgG searches the high-density SNP database, not STR database, and IgG can detect both male and female relatives. This is the typical workflow of IgG. Usually, the law enforcement agencies or crime labs will outsource the whole workflow to the external service providers, and the service providers will use microarray or whole genome sequencing technology to generate high-density SNP profiles from the case, for example. And to obtain a meaningful searching results, usually the service lab will require at least 1 nanogram of DNA from the sample. And the SNP profile will be searched against the SNP database like GEPmatch to look for the potential relatives. And the GEPmatch uses an algorithm to measure the IBD segments between a pair of SNP profiles and determine their relationships. And with enough number of SNPs, it can detect very distant relationships, like the 4th degree or 5th, 6th, very distant relationships. These first 3 steps probably won't take too long to finish. More efforts would happen in the last step, the genealogy search in the public records. It relies on the individual genealogists to dig into the public record and find or confirm the relationships. So it may take weeks or months to get it done, and there's no automatic software available to do this. So it's very labor intensive. The most famous IgG case was the Golden State Killer case, and I believe all of you heard of this case. This was also a serial killer case. In this case, a SNP profile was generated from the crime scene sample and a search against the GEPmatch database. And based on the search results, 25 family trees were generated as potential relatives of the perpetrator. And then the other information was used to rule out the unrelated candidates like the age, gender, the place of residency, etc. And eventually only D'Angelo was left, and he was found through third cousin relationships in a huge family tree with about 1,000 people. So you can see there was lots of work involved in the genealogy search, and much more intensive than just generating DNA profile. I talked about 3 different indirect DNA database searching approaches. Next, I would like to compare them from multiple different perspectives. Both familial search and Y database database searching are conducted in the accredited forensic DNA laboratories and use this validated standard forensic technology to generate either autosomal STR profile or Y-STR profile by the DNA analysts. But IgG usually was outsourced to the external service provider, and those service provider usually will use either microarray or whole genome sequencing technology to generate high-density SNP profiles. but those technologies are not validated by forensic labs. The forensic technology are more sensitive. It can generate full STR profile with about 125 picogram of DNA or even lower. And the IgG service provider usually require at least 1 nanogram of DNA to get meaningful SNP profile, but the more the better. Familial searching searches against the autosomal STR database like CODIS. Y-STR database searching searches the Y-STR database. Both STR databases are managed by the government usually, and the profiles in those databases are verified and the database are secured. But the IgG search against the public accessible database like GenMatch database, and the profiles in those databases are usually uploaded by the average people like us. So the profiles are usually not verified. So in the databases are less secured and more vulnerable to attacks. And the data leakage can happen by hacking or special designed queries. There have been at least 2 papers talk about how to use special design query to get the SNP profiles out of a GenMatch database. All these 3 approaches use different data, so the way to measure the relationships are different for different approaches. The familial search use like a ratio or number of shared alleles or IBS to measure the relationship between a pair of autosomal STR profiles, and it can detect the first-degree relatives. Y-STR database measures the number of mismatch loci or steps for a pair of Y-STR profile, and theoretically it can detect all males in the same lineage. But if it's too far away from each other, then the mutation accumulates, so it will make it more difficult to detect the very distant male relatives. The IgG measures the total length of IBD segments between a pair of high-density SNP profiles, and sometimes it may also use IBS to determine the relationship. And depends on the number of SNPs in the profile, it can detect very distant relationships like the third degree or more distant relationships. There's no official summary on how many successful cases on each approach, but based on the literatures and the information we know, for familial search, they probably have several hundred successful cases, mostly in US and Europe, and several hundred successful IgG cases, mostly in US, and there are probably at least tens of thousands successful cases for Y database search, but mostly in China. In terms of the cost, both familial searching and Y database searching happens within the crime labs, so it can use existing instruments. The cost of the DNA test will depend on how many samples you want to process. It may cost several hundred to several $1,000s. If you don't have a Y database and you want to build a database by retyping all the reference samples, then it may cost a lot of money. But if you just accumulate all the Y profiles generated from the regular cases, then it won't cost anything. The IgG, if you want to do the IgG within a crime lab, you need to purchase a very expensive instrument and maintain the instrument, very expensive. And so that's why most of the labs will outsource IgG service to an external service provider, which may cost several $1,000s or more, depends on the case. In terms of the turnaround time, familial search and Y database search usually only take days to weeks since they happen within the crime lab. In IgG, may take longer, weeks to months, because of the extensive genealogy searching. There's one thing I want to point out here is that the Y database search may also need genealogy search for some cases. Now, the identity of the profiles in Y database usually are known, so if you get a hit, then you know who to investigate. But if the relationship is too distant, you are not so sure if the relationship is true, then you need to have a genealogy search to confirm the relationship. Also explore the other relatives around the hit. So in terms of legislation, familial search are allowed by at least 12 states in US and many other countries, but it's prohibited by Maryland, Washington DC, and Canada. Y-STR database searching covered by the current legislation for autosomal STR database, since the current DNA law do not specify which marker to include in the database. And IgG, there's no legislation as of last year, no regulation for IgG, but it has been introduced and proposed by multiple states in the US, either banning or regulating IgG, depending on the states. The advantage of the familial search and Y-STR database search are that they use existing technology in the legislation. The technology are validated and the proficient tested. The data are verified and secured. Familial search can only detect first-degree relatives, and it may generate large candidate list after searching, so it will still rely on Y-STR to fill out the unrelated. Y-STR database have higher searching efficiency for male lineage, and sometimes we can even associate Y to surnames. But it can only detect male lineages. And if you don't have a Y database and you want to retype all reference profiles, then it may cost a lot. But if you just accumulate the Y profiles for regular cases, it costs nothing. And IgG is able to find the distant relatives and the female relatives as well, so it's better than Y. But the technology is not forensically validated, but probably okay since it's just for investigative purpose. IgG is heavily reliant on the public SNP database, and but the SNP database may not be secure, and the people have lots of concerns on the privacy intrusion. And it also heavily relies on the genealogist to do the public record digging. So it will take a long time, and there's a lot of effort involved. In a short summary, all these three approaches are viable and can increase the value of DNA databasing. Y-STR searching and IgG are more advantageous things. They can detect more distant relatives and should be able to assist in more challenging cases. But familial searching can be performed more readily within the current forensic lab settings. The database is the key. Without database, there's nothing you can search, right? In the US, autosomal STR database and the genealogy database are ready for search, but many other countries, they may not have the genealogy database ready. In the US, probably not too many labs have their own local Y database, but if you start accumulating your Y profiles through regular cases, and in the future, I believe you will have some good surprises. Just like many years ago, people upload their SNP profiles to GenMatch database. And each country or state may have its own unique situation in economics, technology availability, culture, legal considerations. So each state or each country should decide the best approach to fit those circumstances. In our center, we have touched all three approaches. I developed a familial search software, NPKin FS Edition, many years ago. It has been used in many crime labs. And if you are interested in this software, you may contact me or the tech transfer office in our university. I believe our tech transfer office have decided to provide this software for free or really low cost. Currently, we have a NIJ-funded research project to use high-density SNP panel for missing person cases. The challenges are how to get good SNP calls from the bone samples, relatively great samples, and also how to develop a a good algorithm to deal with those low-quality SNP calls. And I'm also working on a pilot local Y-STR database project, and hopefully in the next few years I will have some good stories to share. Finally, I would like to thank the invitation from my friends in Thermo Fisher, Angie, Sherry, Christina, and Jonathan. And I would like to thank the support from my colleague in UNTCHI, Bruce, Don, Christina. Also, I would like to thank Wak, Brian, Colin, Chris, Sally Ann, and Carol for providing their data in this study. Thank you, and now I will pass it over to my colleague, Wayne Wickenheiser.
Thank you, Mike and Dr. G. And I'll start with my presentation now on the forensic applications of Y-STRs, cases, and databases. So my name is Ray Wickenheiser, and I'm the director of the New York State Police Crime Lab system. Just first for a disclaimer, any of the opinions that I'm going to express are those of myself, not the New York State Police, ASCLAD, or any other entity. So just to provide you with a brief outline of what I'm going to talk about with you today. First of all, talk about investigative leads and what we do in forensic labs and what our process is. I'm going to talk about Y-STR case applications specifically and give some concrete examples of some great case successes we've had, starting with the Anna Shove case, which is a great Y-STR case, followed by familial searching cases, one of our big successes in solving decades-long unsolved case of Wendy Jerome homicide in Rochester, New York. I'm going to talk about familial searching in New York, what we do, and some of why we do it, and then also touch upon investigative genetic genealogy. And then to summarize, provide a path forward, and that is how do we provide data-driven investigative leads. So to jump into my talk, evolution of forensic science. Things have come a long way in the last number of decades. So what is forensic science? Really the application of science to the law. And the mission we have in crime labs is, as we're applying that science to law and our cases, our goal is to maximize the value of evidence. So we're in a privileged position where we provide independent scientific analysis. It's objective, it's based on data, it's reproducible, and it's something we can demonstrate. And so that adds a lot of value to investigators and investigating their cases and to the justice system as a whole. So the services that we provide, we identify items. So you think about drugs, toxicology, is it blood, is it semen, fingerprints, and so forth. Comparing it to known sources adds a lot of value. Now, where did that blood or that semen come from? And providing those associations. So we absolutely can eliminate sources, potential sources with certainty. So that's great and very valuable, especially those people are being eliminated. And when we include somebody, we can give an idea of how much weight is and how valuable or how probative is that inclusion. So that adds a lot to investigators and the judicial system. And what I really want to emphasize today is the investigative information and helping investigators develop and eliminate suspects is really a great service. It's something we provided for years, but has really come to the fore with some of the tools we have now, which I'm going to discuss. So when you look at some of the new investigative tools, and by new, you may be saying, well, Y-STRs aren't that new, but relatively speaking, they are, and some of their applications are. Familial searching, again, I'm talking about that in the case. Investigative genetic genealogy has really come to the fore in being able to solve decades-long cases. So again, a great technique, and I'm going to talk about that a little bit. So what you're really seeing is a shift from direct one-to-one matches where you had to have a suspect. Now using databases, we're able to provide those investigative leads in terms of here is a person of interest where there was not one previously before using a database. Now we're expanding comparisons, particularly with familial search, to include kinship information, and that's a bit of a mental leap. So we're not doing a direct comparison, but in fact an indirect comparison, but using DNA and our knowledge of how it is inherited can really add value in terms of expanding the size of that database. And something, again, the privacy advocates have a point, something we want to take very, very carefully and sensitively, but it does add value to investigations and really, again, back to our mission, and that is maximizing evidentiary value. So when do we do this? So right now, we certainly are reacting to investigator requests. They're asking what cases and demanding cases be done. But certainly we have potential crime labs because we're an aggregator of data. People make a lot of requests from different jurisdictions, and those go into our backlog and eventually into unsolved cases. We can review our cases for candidates in terms of which cases are potential candidates for this new technology, and then reach back to to our investigators. So it goes both ways. They ask us, now we're in a position where we can look at what we have and say, hey, have you thought about this for this case? So speaking specifically about Y-STRs, as you may know, the Y chromosome is for males only or in males only. So only certain kind of cases where there is a male. Of course, that's a lot of our cases, as males are suspects the vast majority of the time. But because all the short tandem repeats or STRs we look at are linked, we can't use the product rule, which means if they were independent, we'd multiply them together. That's not the case. So hence we have to apply much more conservative statistics, counting method, and so forth. So as a result, having the same Y chromosome match with an STR profile is going to be a lot more common than autosomal inclusion. So it's really not as individualizing. But what we really can use them for when we have a Y as in a male who's in a mixture with a female, which is quite often the case, particularly when you have sexual assault cases, there's abundance of female which may drown out effectively that minor male component. That's where the Y-STRs is very, very valuable. And it's also when you have a relative who's a male, so if we're searching for male candidates, such as what we do with familial searching, using that Y where you know the autosomal is different, but using the Y as a tool to eliminate really lets the DNA do the heavy lifting for familial searching. So we can much more quickly eliminate candidates, whereas if we just dump that whole list on investigators, that would really be overwhelming. So that's where the lab can really provide a tremendous service to let the DNA do the work. So the first case I wanted to discuss was a great Y-STR case success in a homicide case. August 10th, 2014, the body of 17-year-old Anna Rose Chauve was pulled out of Lake Ontario at Brennan Beach. She was vacationing at an RV resort near the beach with her family. There was some initial suspicion that Anna's death was more of an accidental drowning because she was a pretty good swimmer, but because there was other factors, including she had some bruises cut to her head and around her eyes and her mouth, there was some suspicion. So certainly any unattended death as this, you would look into it, and there certainly was some clues that indicated perhaps it was not an accidental drowning. So a number of items were submitted to the crime lab. There's a sexual offense kit that was collected after her autopsy was submitted. The date that's indicated there on my PowerPoint slides. There was additional items, including her bathing suit, purse, that were found in the lake and notably were weighted down with rocks, and that was submitted. So again, evidence there that perhaps it was not an accidental drowning. Other people on the beach that day indicated that she was seen with a 32-year-old man named Stephen Satanic. Hope I'm not mispronouncing that too badly. And a buccal sample was collected from him and submitted on the date also indicated in 2014. He had a visible scratch on his neck when questioned by state. And again, I just want to note all kinds of cases, particularly DNA and especially Y, it's part of the entirety of the case. So somebody's not going to be convicted on just the Y-STR alone, but nor should they probably on DNA alone. You're really looking at the composite of the case. So what you can see is a picture that's starting to become clear here. So the DNA report was issued also in 2014 on samples from the autopsy and swabs from her bathing suit. And very notably, a Y-STR DNA profile from the fingernail clippings and scrapings from the right hand of Anna Rose Chauve matched the profile of the suspect. Really interesting to me is she was found in the water. There was not an autosomal profile, but a Y-STR. So we'll take what we can get. To me, it was just astounding that we're able to get a result given the situation that her body was found in. So remarkable work there, and obviously great tools help you do that. So less than 4 hours after deliberation, the jury found Mr. Satanic guilty of second-degree murder in Anna Rose Shope's death, and he was sentenced to 25 years in prison. During the trial, he testified in his own defense. He admitted he had spent some time with her on the beach and hugged her. He stated that he hid her purse after finding what he thought was a suicide note. He also claimed he took her other belongings, including the note, to a different beach where he built a memorial to her. And obviously, if you're a juror, you have to decide, whether that's something you want to go with or not. And it certainly helps to have objective evidence of the DNA that's helping you to make that decision. So the next case I wanted to focus on was Wendy Jerome, a familial searching case, which we very recently had success on. And so this was a decades-old homicide case committed in 2014 in Rochester, New York. So then 14-year-old Wendy was last seen alive leaving her home to deliver a birthday card to a friend around 7 p.m. on Thanksgiving Day, and she had an 8 p.m. curfew. When she didn't return at 8 p.m., her parents were frantic, reported her missing. And very sadly, her body was found less than 3 hours later behind a school very nearby her home. She had been raped, brutally beaten, and her throat had been slit. So here's just a summary of what was quoted in the paper. What is familial searching? In the familial search, we use an algorithm to compare people in the data bank. So we're talking about the CODIS data bank to this crime scene sample and look for relatives. So we're looking for an indirect match. There was a full CODIS profile developed with no hits for a number of years. So we're really trying to expand that search, develop investigative leads that we can provide to investigators. So a suspect was arrested, and I just want to note for everyone, this is just an arrest. Individuals are innocent until proven guilty, so this is preliminary. But just for your background, they were 20 years old at the time. They lived near the homicide scene in Rochester at the time. The two individuals did not know each other. The suspect abruptly moved away from Rochester. They were arrested in Florida, and a trial is pending. So I do want to, after highlighting these two cases and the success we achieved in it, talk about just how we do familial searching in New York. So currently we have kind of a unique process in which we have a Department of Criminal Justice Services, DCJS, where the application is actually made to that department. And we are the lab that would essentially be the wet lab for that administrative body. So the request is submitted to DCJS. It must be a homicide or sexual assault or with exigent circumstances, so a major public safety threat, where significant resources have been expended to try to solve that case. There must be, at this time, a full DNA and full Y-STR profile in CODIS with no hit. There must be a signed MOU from the police chief and the DA. And the New York State Police Crime Lab then conducts a familial search once those cases have been vetted and approved through a process. We use Y-STRs once we have generated a list, and with essentially we take the entire database, state database. We generate a likelihood ratio comparing it to essentially how likely is each individual related to this crime scene profile. And then we assess essentially the top candidates. And any of those that have a threshold, and again, depending on how many loci we have in there, whether it's 15, the threshold is 10,000 likelihood ratio, and 5,000 when we have 15. So once we've met that, we then let the Y-STRs do the work, as I had mentioned previously, and sort through those samples so we can then ideally provide someone who has meeting the likelihood threshold and also has the same Y-STR profile. So we had an extensive validation process that was reviewed and approved by our DNA subcommittee, because we have a commission and DNA subcommittee that oversees all of the crime labs within the state of New York. So that was approved, as I mentioned, by the DNA subcommittee, as well as the New York Commission on Forensic Science. So as I mentioned, likelihood ratios, we have a threshold that they must meet, and then as well as the Y testing. We currently have a validation expansion in the approval process, which we're moving up to the 20 loci. And we have also included a much higher threshold that will remove that requirement for the Y-STR profile. So that's really for cases where we have a female suspect or we don't have a Y-STR profile available, because we may have those kinds of cases where we just don't have enough DNA. So what it's doing is really expanding the candidates that they don't have to have that full profile. And we have roughly 15% female in the database, so we want to be able to look at those kinds of cases as well. I do want to touch upon IgG, or investigative genetic genealogy. And what that is a generation of a SNP profile, which is not the STRs we typically deal with in a crime lab. No crime labs, to my knowledge, are doing them, so this is an outsource where we still have some DNA that is at the crime scene from that perpetrator. We want to put it into a database as in that SNP profile, and those databases are direct-to-consumer databases, not law enforcement databases. And somewhat in the same way as we do with familial searching, essentially get a relative who's a suspect and then work with that potential candidate, if you will, to see if there's any potential there, develop family trees and whatnot. So just to give you a little bit of an idea, I've broken this into 3 phases, how IgG is done. Phase 1, exactly what we do now, go to the crime scene, get that DNA, develop an STR profile, put it into CODIS. Phase 2, which I'm going to focus on a little bit more, is really that genealogy component, which is new to us, new to crime labs, and can be done totally externally to a crime lab. And then back to phase 3, which now the investigation has a suspect, gets a known sample, bring it to the crime lab. We do an STR profile and do the direct comparison. So phases 1 and 3, entirely what we're used to, done in a crime lab. What's new is this phase 2. But it's the key of how we get a suspect, and I do want to kind of touch upon that as well. So we're in the process of working on cases, as many of you are, within the state police, and we've looked through our cases to come up with candidates, as well as talk to our investigators, and they've been able to submit cases or talk to us about cases that way as well. So talking about phase 2, just how that is done. So once we do have sufficient sample, that's both quality and quantity, so we're looking at least an anagram at this point, and working with whatever outsourced labs in order to make sure that there's a sufficient quantity there. They will develop the SNP profile from the crime scene sample. The next phase is for that to be put into those couple of databases, notably GEDmatch and Family Tree, that do have individuals in the databases who are permitting their samples to be used to be searched against, and candidates are then surfaced. So they're known as matches, but essentially they're potential relatives. And from those potential relatives, a genealogist can then essentially build a tree to look for a most recent common ancestor. So what that is really doing is going to, if you have somebody who, say, is a first cousin to the crime scene, that would mean that you'd have to go up to grandparents. If the second cousin, you'd go up to great-grandparents and so forth. So you're looking at somebody who is a most recent common ancestor of the candidate that you've got a match to and the actual crime scene. Then once you've had that most recent common ancestors, you've got somebody who's an ancestor in common, you build the trees back down and then look for descendants. And then once you have those descendants, you're looking for where the family trees may actually cross, because ideally you'll have multiple individuals. And ultimately, you're looking for step 6, which is now you've got those family trees, you've got somebody who has both sides or relatives on both sides that come together in one family. So you got somebody on the maternal and paternal side, and then descendants that fit the profile. So they've lived in that same location, they've been the right age, they are the right sex, typically male, other attributes perhaps that you might be able to include, hair color, eye color, if those are the kinds of things you're able to develop in the SNP profile, and hence develop a suspect. So a lot of work there, but again, the same goal as familial searching is a number of the other things we do, developing something, a lead that we can turn over to our investigators, and again, back to what they're known to be doing, get that profile, and then get it back to the lab so we can do the direct STR comparison. So one of the things we really, again, my opinion, really emphasize is always having the CODIS eligible crime scene profile before you proceed. We want to have a kind of constant flow and treat the cases the same and equitably, and how you're going to do that, and use the kind of most reliable techniques that are going to solve cases first, and then build upon those in the cases that you have not solved. So what we're doing here, and what I would really subscribe that we would all do, is apply both all of your techniques to whatever policies out there, Department of Health policy on conducting investigative genetic genealogy, and it's very, very similar to what we're doing with familial searching. So we're restricting it to major cases. I talked about having sufficient sample, and by having a CODIS profile first and not getting a hit, what you ensure are the followings. One is that it sounds so simple to say it. It's a CODIS qualifying profile. But what that does is guarantee a whole lot of other things. One is the profile is quality. It's been generated in an accredited lab that is audited to the FBI QS. It's got all of those requirements that we all know. If we're in a crime lab, you're audited, you're proficiently tested, you have qualifications, all those things I've listed and more. It's independent objective, as in you've developed that profile from a sample you know is at the crime scene reasonably from the suspect. And you're going to do that well in advance of having any suspects to compare it to. So it's going to be independently done. It's objective. It's going to be probative. Ideally, you've got that smoking gun, so to speak, of DNA that's found in a really telling evidential position, and sexual assaults with semen, that kind of thing would obviously be that kind of sample. Equitable, and as I'd mentioned, using the CODIS first and then progressively layering the more aggressive approaches to solving your crime ensures that you're treating cases equally. You're doing it in a very organized and a good flow, kind of good manner that's very consistent. And then you ramp up the efforts for those cases where you would have unsolved or haven't solved them by earlier efforts. So it really helps to have that organized flow, treating cases the same and equitably. So the key components, I guess in summary, in maximizing evidentiary value of the crime scene evidence is to use that kind of a layered progressive approach, and really using technology that we have to save investigator time. I mean, they're fantastic, but they can only do what they're given in terms of tools. So using the Y-STRs, as I'd mentioned, for familial searching, and limiting a number of candidates to ones that are really ones that, you know, you can say are strong candidates, but including training as well as that, knowing that these are family members. We really have to treat them carefully. They are not the suspect, but you're getting close. Using databases responsibly, abiding by terms of service. So I mentioned letting the DNA save and direct investigative work, and of course the great example, Golden State Killer, that really started it all. Unsolved in 4 decades with traditional techniques. Along comes investigative genealogy and some fantastic work, solved in 63 days from the date of that database entry. That speaks for itself, but something we really have to use carefully and judiciously. As I mentioned and demonstrated, how we use our familial search screening, using those Y-STRs to screen the candidates, again, protecting their rights. So we really want to give leads that are, you know, ones that we know are as good as we can make them. Having MOUs with law enforcement and prosecuting attorneys to make sure that if we're going to do the work, which is considerable, that they're ready to move ahead with that case. And having that training to ensure that the leads are known to be related individuals, not that individual, and so that it can be something that really is done properly. So we want to make sure that we use the tools judiciously, and we make sure that they're there for the next case and the next case and next case, and something that everybody can get behind, given that there are privacy issues, and we really want to be respectful of that. So providing investigative leads to investigators has always been one of the most important jobs of the crime labs. And so these tools are providing more of the same. With that, I'd like to acknowledge some fantastic efforts of our biological science casework, data bank, and CODIS staff who worked on these cases and on our familial searching and investigative genetic genealogy initiatives. So thank you for your kind attention. And with that, I'd like to open us up for some questions.
Fantastic. Thank you, Ray, for that great information and insight. Audience, it is almost time for the Q&A portion of our webinar. If you have not already, please take a minute to ask our presenters a question using the Q&A dialog box on your screen. While you think about your questions, we're going to throw up 3 polling questions for you quickly. The first one, does your agency utilize Y chromosome analysis? Yes, Y-STRs for sexual assaults, Y-STRs for homicide cases, Y-STRs for mixture analysis, Y-screen for sample screening, or no? Let's see what everyone says. Looks like the majority of you say no, followed by closely by yes, you use Y-STRs for sexual assault cases. All right, let's move to our second one. Has your agency used familial search or genetic genealogy? Yes, we have used familial search. Yes, we have used genetic genealogy. no, but we plan to use familial search in the future, or no, but we plan to use genetic genealogy also in the future. See what you guys said? Yes, you have used it for genetic genealogy, which makes sense since it is one of the fastest growing disciplines within forensic science. All right, last question. Would you like to receive more information on today's webinar topics? Yes, please contact me about Y-STR analysis. Yes, please contact me about Y-screen. Yes, please contact me about autosomal STR analysis. Yes, please contact me about other ways to generate investigative leads. Or no, not at this time. Let's jump into our Q&A then and answer any questions that have come through the console. All right, presenters. Our first question is, can Y-STR analysis discern the differences/similarities between father-son and then onto more distant relationships such as uncles and cousins?
I can answer that question.
Great.
So in general, you see the more distant relatives will have more mutations between each other. So, but if you compare the father-son pairs and the cousins pairs, the difference is not that significant. But this you may use there's no clear cut you can differentiate the father-son pair and distant male relatives. But to differentiate the males in the same lineage versus the unrelated, you probably can use with Y-father plus, for example, you may use 4 or 5 mutation steps to make to differentiate the relationship or not. But hard to tell if it's what relationship.
Okay, great. Thank you for that. Next one, both of you talked about genetic genealogy. Are you familiar with many cases from outside of the U.S. where agencies are using genetic genealogy to generate leads?
I have seen some reports. Out of the U.S., there's been some cases use high-density SNP panels to solve some cases. For example, there's a report by a group of research from Sweden. They use the whole genome sequencing data search against a match database to determine the identity of a missing person, and they were able to narrow down the region to a particular country, Croatia. So I would say that's a success by providing a investigative leads. Eventually, I'm not sure if they eventually determine identity, but at least they provide some investigative leads. And also, there's other countries like China and other countries. They're also trying the genealogy technology.
Okay, great. Next question. Generally, what are the criteria used to determine if a case would qualify for familial search?
Okay, so I can take that question, Johnny. So the criteria that we typically use is that you have a full profile on CODIS with no hit, and that automatically includes all those quality things that I had mentioned previously. Also that we've and I don't like the term exhausted all investigative leads. You've certainly put a lot of energy into that case and it remains unsolved. So I guess the question is, are all the leads ever exhausted? So we tend to just stick with a lot of investigative energy has not been able to solve that case. We have a full profile. It's a major case, so we reserve these really for sexual assaults and homicides, and that is really a probative sample. We do have an MOU that we put into place that ensures that the investigative agencies are willing to proceed with the case. So we really want to spend all this effort on a case that is going to more likely yield some results. So those are the things we have in place in New York State.
Okay, perfect. That leads into our next question for you, Ray. What kind of information is included in the MOU between the lab and the police/DA's office? And just in case someone's not familiar, can you give us the acronym for MOU? What does that stand for?
Sure. Thank you very much. So MOU stands for Memorandum of Understanding. And what we really want is some kind of a commitment because these are cases that we're going to go through a lot of additional effort to do not only the statistics on it, we're going to do a bunch of Y testing and sort out with additional testing some investigative leads. So we want that memorandum of understanding on both sides of the investigators to say this is a case that this will really help them, that's not solved, that it meets the criteria, but also on the prosecutor side, the lawyer, is this something that with the positive result and they find somebody, they're going to pursue it. So we just really want to make sure that all the parties that are at the table, that it meets the criteria, it's an unsolved case, the lead is going to really help the case, and they are going to move ahead. And what we have found is there have been a number of cases that at the lab, we think they're still in pursuit, but the case may have been solved some other means. This is just a way to make sure you're going to put on in this additional effort. Everyone is committed to move forward, and it's actually on paper so we can get that commitment. So that's what we do, go the extra mile just to make sure everyone is.
Okay, absolutely makes sense. All right, Johnny, we have a few questions for you, so let's grab you back in here quickly. In Chinese laboratories, which Y-STR typing kits are typically used?
So they mostly use the Y-Planum developed by Thermo Fisher, and then the few other kits developed by Chinese local companies. But mostly they use Y-Planum by Thermo Fisher.
Okay, let's stick with China for a second. You know, with less than 35 Y-STR loci in the Chinese database, how many hits do they get per Y-STR search typically?
So it will depend on the criteria you set. Depends if how many mismatches you allow. Totally, so let's say you have 35 markers to search, and then you allow up to like 3 or 4 mismatches, then you will get more hit than just 4 match, right? Typically, they will get about 10 to 20 on average hit. It's a 4 match in a database.
Okay, let's turn to Y-STR databases in the U.S. How many Y-STR databases with reference profiles exist in the United States?
I'm not sure how many, so I don't know the answer. I think the labs are allowed to upload their Y profile to CODIS, and there's no statistics on how many Y profiles in CODIS. Okay. And not necessarily all the profile upload to CODIS, so some labs will probably already accumulate some Y profiles in their local LIMS system or something. So, but there's no such kind of statistic.
Okay. And now you could both probably answer this, but let's start with you. What are your thoughts on Y-STR database searches when you don't have an autosomal STR profile?
That's fine. So it really depends. If you have a Y database to search, yes, then you just search it. You don't rely on the autosomal STR database. When you get hit in a Y database search, then you can just investigate the hit family. So then you type the autosomal STR profiles from those the family members. Then you don't rely on the autosomal STR database.
Gotcha. Okay. Ray, anything to add there?
Yeah, and I would add, anything that provide a lead can be of value. I guess the challenge with Ys is because it's not going to be specific to that male, but include anyone in that whole patrilineal line or that whole male side of the family line. The challenge there is that you're going to look at folks that are not the perpetrator. So as long as the investigators are well advised, and hence the training part, just to know that you have to be extremely careful with folks that they may help you get to the suspect, but they're not the suspect themselves. So it's just that taking the care that you're going to get other folks that are included that are not the perpetrator. Whereas with autosomal, we're used to when you get an inclusion, it's that person as opposed to this indirect information.
Gotcha. Okay. All right. Another one for you, Ray. Is there a main reason why most NDIS participating labs haven't incorporated IgG into their toolkit? Is it cost? Is it something else?
Yeah, so it's actually several. Certainly, it's costly, and it takes not only the cost part, it's time. And any new technology, like this is really, we think of it as it's old news. It happened 2018. In terms of forensic timing, that's very quick. And so because it's technology that typically we don't have in the lab, to get the instruments in, to do the full validation, that's a big lift for many crime labs where we're already in a backlog situation. So it's a kind of combination of the time, the instrumentation, but it does come down to cost and resources as well. But to come up with that kind of overnight is a big challenge. So right now, everyone is outsourcing or sending to labs that are not kind of traditionally forensic or crime labs. Over time, I think it's something that a number of us will be looking carefully at. This is something we can bring in-house, apply our forensic expertise.
Absolutely. Okay. Jean-Yi, let's turn to you quickly. The familial searching software that you created, is that used by the Texas Department of Public Safety CODIS lab?
Yes, the answer is yes. And the Texas DPS lab was the first lab using the software. Yes.
Oh, okay, that's great. We have a question about the X chromosome. What do you think of the X chromosome? I mean, is it helpful for forensic investigations, or is it not really of great use?
I would say the X chromosome may be useful for certain kinship analysis cases, but probably not a best tool for searching relatives in the database. First of all, usually you don't have STRs in the database. And also, even if you search, it's very, very complicated. It's not as simple as Y or autosomal. So I would say X chromosome has very limited value in database search.
Okay. Now, this is kind of a broad question, but maybe you can at least give us some insight into how are databases validated, certified, accredited? How are these things regulated, and that we can use them?
So I can probably jump in and take that one.
Okay.
So certainly for any of the databases, and I'll call the NDIS databases, the National DNA Index System, those are regulated by, I believe, the DNA Identification Act of 1994. So there is a requirement that anybody who participates in those NDIS, we call them kind of CODIS as an acronym, but databases have to be accredited. They have to adhere to the FBI quality assurance standards. So you've got all of that mandatory requirements. You've got to be audited externally every 2 years, internally every year, kind of offsetting that. Proficiency testing, a lot of requirements. So accreditation and that mandating just makes sure that there's a lot of oversight. Then a lot of it is the security aspects and so forth. So I feel that databases that are with the end system are extremely well regulated. Now the challenge when you go to the direct consumer is, while those companies may very well look after them because it's their business, so you would expect they are, but because it's not under the law or those kind of mandates, there you've got terms of service and all of those things that are used for genealogy, and that's because it's outside of the crime lab regime. That's really kind of up to those companies. But I'll just say I have a tremendous amount of confidence in the quality and the integrity of the NDIS system and the CODIS profiles that are put into that system.
Absolutely, it's important. Okay, Jean-Yi, another one for you. Are you using microarrays to generate a high density SNP profile, or are you using whole genome sequencing to then create the SNP profile to upload into GEDmatch? So
in our center, we are testing both technology for missing persons cases. Both microarray and whole genome sequencing. We're still working on that, and the initial data shows that the microarray has pretty good sensitivity, better than what we expected. But in the future, we'll probably have more data to ensure.
Okay, perfect. So earlier in your slideshow, you showed a indirect database searching comparison chart. Is there a way to access that after this webinar is concluded?
Yes, it's on what the table is actually, it's part of the paper I published, and you can send whoever wants to have the paper. If you don't have access to the paper, just send an email to me. I can share it with you.
Perfect. And it's I'll note here, audience, that this webinar will also be available on demand on the Forensic website. So in addition to you can get the paper, you can get the chart from the paper, you can come back and watch this anytime you want, and you'll be able to see the chart. And we got time for a few more questions. Let's run through them. Maybe just a couple more. All right, Jean-Guy, what about a mitochondrial DNA database? Can you kind of talk about that and what that would be like?
So I believe CODIS allow you to upload mitochondrial DNA profile to CODIS, mostly for the missing person cases. But probably the number of samples probably not that big in CODIS. And but we do know that the KLDOJ did use mitochondrial DNA screening in one of their familial searching case. So it shows that mitochondrial DNA definitely can be used in familial search. Yeah.
Okay. For familial searching, have either of you considered searching anything less than a full autosomal profile?
So I can speak to that one. So the quick answer is yes. When we started in New York, because we were given a very quick mandate to get familial searching up and running, the original policy was for full profiles only. However, as we gained experience, we've now done a validation with less than full profiles. We've had to increase our likelihood ratio just to make sure that we're not getting adventitious hits. We want to kind of narrow those candidates, the ones that are more likely to be actual relatives. So we do have a proposal that is before our DNA subcommittee and commission that allows us to work with profiles that are not full profiles. So certainly somewhere there's always a line, there's always a bar, but we really want to try to provide good investigative leads. But because we're using Y-STRs to help us doing a sort there, it really does, we're letting the DNA do the work in terms of doing extra lab work so our investigators can really have much more targeted leads. So we are hoping to get that approved in the near future so we can expand the types of cases that we look at.
Okay, great. Let's wrap up here with two more IgG questions. When you're working with IgG, how do you separate the mixtures for the IgG casework?
So I can probably speak to that too. Our challenge there is we're really using technology that we're not, it's brand new to us in the crime lab. We're new to SNPs. So because that's the profile we're currently looking at, we're relying on those vendor outside labs. And at this point, you really need, or you have to have a profile that you can subtract. So you can deal with a mixture, and it's typical like sexual assaults where you're going to have the male assailant, a female victim, and if you have her profile, so to speak, it's about a 50-50 mixture, they can subtract that out. So you can deal with straightforward two-person mixtures. In rare circumstances where you have a very minor component at like a 10-to-1 ratio, they can just subtract that out. But it's really limited to that much more simple mixtures where you have the full known profile of one of those two people, which typically is going to be your victim. So there can be some mixtures done, but I'll just say it's early, and hopefully as time goes, we'll be able to work more and more with mixtures because we see those in the majority of our forensic casework.
Mm-hmm. That makes sense. All right, last question, and it's a good one. It's an interesting one. Do you think that the general public S&P profiles added to GEDmatch, let's say, will decrease in the future and be limiting for IgG?
So I actually think that it will go the other way personally. And of course, I'm very sold on what we do, and I think we're going to take care to do it correctly. I feel that as the public becomes more and more educated in what great work we're doing, not only to solve these cases, but to identify previously unidentified human remains, I feel they'll get more confidence to allow their profiles to be used by law enforcement or, medical folks to identify, these unfortunately unsolved cases, where someone's gone missing. So over time, I think that will just grow as people become more knowledgeable. But again, we'll see how it plays out. But so far, when you look at the cases that have been solved, I think the product speaks for itself. And, again, we just have to be very judicious in its use and make sure that no one makes any missteps in terms of privacy and so forth.
Absolutely. Okay. All right. Well, audience, that about wraps up the time we have for the Q&A. In 24 hours, this webinar will be available on demand if you would like to watch it again or share it with friends and colleagues. Additionally, you will receive an email with information on how to obtain CE credit documentation for your participation today. Thank you for attending the first webinar in the 2021 Future Trends in Forensic DNA Technology series. The 5-part series continues on April 1st with a rapid DNA booking station, implementation considerations, and best practices. You can register now on www.forensicmag.com. Please be sure to check your email for more information on how you can obtain CE credit documentation for your participation in today's webinar. And we look forward to seeing you next time.